Hi everyone. I wanted to take a quick second and clarify that example 3 that we ran a little short on time for in class today. So example 3 had to do with combining these fractions with these crazy denominators and everything. And I talked a little bit in class about the process of clearing the fractions. So before I get to this first example, let's just talk about that again. So let's suppose I had this problem that I was trying to solve. You certainly could go through and find a common denominator, okay, and combine them using a common denominator and just work with the fraction all the way through. There's nothing wrong with that, and I'm going to show you that process in just a second. What I want you to consider is a method called clearing the fractions, which shortens things up by a step or two, okay? So what I can do to clear the fractions is I can take the entire equation, notice that includes the 10 over here, and multiply by whatever my common denominator would have been with the 7 and the 5. Okay, so in this case, I would multiply everything through by 35. Okay, and that means I'm multiplying over here by 35 as well. But I do want to point out that the reason I chose 35 is because that's really the 7 and the 5 together. Okay, it's really like I'm multiplying by a 7 and I'm multiplying by a 5. So what ends up happening when I do that is if I do x over 7 times 5, okay, that's what I'm saying here, times 7 times 5, the 7's are going to cancel, and I'll be left with just the 5 and the x. So this would become a 5x, okay, plus, and then in that next one, if I multiply by 7 and 5, I don't know the best way to write this, but the 5's are going to cancel, and I'll be left with the 7 and the x. Okay, so I'll be left with 7x. But in order to do that correctly, I also have to multiply by the 7 and the 5 over here. And again, just to remind you that 35 is really like multiplying by 7 and 5 because I don't have anything here under the 10 that's going to cancel with the 7 and the 5. So over here, this is just going to equal 350. Okay? And this equation now, the way it's written, is a lot easier to solve because now I don't have these ugly fractions. Now I can just put these two together and make this 12x equals 350. And I didn't make this so the numbers was going to come out nice. I don't really care so much about the solution, but from here I think you know that you would just divide by 12. Okay? Now, if you hate that, if you really think that's a terrible idea and you would rather just work with the fractions as is, you can. So I want you to kind of keep that process in mind. In fact, I might just move it off to the side here. I want you to take a look at this. This is what that sort of traditional method would end up looking like. Okay, so this is where I'm saying I want to turn these both into 35s. So I multiplied by 5 here and I multiplied by 7 here. Okay. That gave me 35s on the bottom of each one. And I'm allowed to do those without messing with the 10. Notice that this time I didn't do anything with the 10 here because essentially these numbers written here in pink are me multiplying by 1, right? 5 over 5 is 1. 7 over 7 is 1. So that's why I'm allowed to do that, okay? But when I do it that way, my next step, I'm still in fraction form. And so I can add them together with my common denominator, but I end up with this 12x over 35 equals 10. And if you think about this step right here, the very next step you would take is to multiply by 35 on the other side. Okay. When you do that, lo and behold, you're going to end up with this, 12x equals 350, which is exactly where we were in the other one, right? But if you compare like the ugliness of this, sorry, it's a little, let me see if I can zoom that out just a little bit. If you compare how this looks to how this looks, even though this looks a little uglier at the beginning, it simplifies down faster, okay? You're not carrying fractions all the way through the problem with you. There is absolutely nothing wrong if you want to do it like this one every single time, okay? I'm going to show it to you using this method because I think it will save you a step or two. Okay, but if you would prefer this, that's fine. I just encourage you to try it this way at least once. Okay, so I'm going to go back through that first example. I know we did that one in class, but if I was going to try to come up with a common denominator here, really x plus 1 and x minus 1 don't have factors in common. So I am just going to multiply everything in the equation by x plus 1 and x minus 1. And then I'm going to multiply over here by x plus 1 and x minus 1. So what's going to happen here when I take these two and distribute to this first fraction? When I multiply by when I multiply by the x plus 1, this and this are going to cancel. And I'll be left with x minus 1 times x minus 2. Plus, then I'm going to take this whole thing and multiply by this fraction. And when I do that, the x minus 1s are going to cancel, but I'll be left with the x minus 3 and the x plus 1. Over here on the right side of the equation, the 2 doesn't have anything underneath it that's going to cancel with either one of these, so they're both just going to stay there, and you're going to be left with this 2 times x plus 1 times x minus 1. Okay, but notice I don't have fractions anymore. That's the whole goal. If you had done it using that other method where you reduced each fraction individually, you would have a giant fraction in this step. But then your very next step would be to multiply by the denominator, and this would end up over here anyway. Okay? So like I said, this is kind of just combining two steps into one to save you a little bit of writing on these problems that are kind of gigantic. So with this first one, let's see, I'm going to do my FOIL here. This is going to give me x squared minus 2x. Oops. So minus 2x and minus 1x, I'm going to do those two together. So I'm really just going to make it minus 3x. And then negative 1 times negative 2 is positive 2. Over here, x times x is x squared. I'm going to go ahead and do negative 3x plus 1x, so that gives me negative 2x. And then negative 1 times 1 times negative 3 is negative 3. Here I'm going to do x times x is x squared, and then I'm going to remember the 2, so that's really going to give me 2x squared. This will give me negative 1x, and this will give me positive 1x, which will cancel themselves out. And then here at the end, 1 times negative 1 is negative 1, times 2 is negative 2. So now my goal, because I'm suspecting quadratic formula here, now my goal is to get everything simplified and move to one side. So if I put these together, let's see, I end up with x squared and x squared, so 2x squared. Okay. Negative 3x minus 2x, so that's negative 5x. And then 2 minus 3 leaves me with negative 1. And then I have 2x squared minus 2. My next step would be to start taking this stuff and move it to this side, but lo and behold, look at what happens. You end up with a 2x squared on either side. Those really cancel themselves out. And so you end up with this negative 5x minus 1 equals negative 2. From there, I'm going to add 1 to the other side. So negative 5x equals negative 1. Oops. And then I'm going to divide by negative 5, and I'm going to end up with x equals 1/5. Okay? Okay. So that would be my final answer. There is one thing I should technically check with this final answer, but I'm going to wait until I get to one where it's an issue, and I'll point it out to you, and then we can come back and talk about it. So let's try that same process again with this next example. So what I'm going to do is I'm going to multiply the entire equation by both denominators. So I'm going to multiply by x plus 4 and x minus 4. X plus 4 and x minus 4. That's going to do this. X plus 4 cancel, and so I have x minus 4 times x minus 3 left over. That's here and here is where that's coming from. Plus, okay, now my x minus 4s are going to cancel, and I'm left with x plus 4 and 2x plus 1. And on the other side, I have, trying to stick with my colors here, 3 times x plus 4 times x minus 4. Now I'm going to go through and do all my FOIL. So x times x is x squared minus 4x minus 3x. So that's minus 7x. And then negative 4 times negative 3 is positive 12. X times 2x is 2x squared. Then I have 1x plus 8x, so 9x. And 4 times 1 is 4. Over here, x times x is x squared, and then I'm multiplying by the 3. Once again, someone was really nice to you here, because this won't always happen, but I ended up with a negative 4x and a positive 4x, which cancel themselves out. And then 4 times negative 4 is negative 16. And I think also someone was really nice to you in the next step, too. So if I go put my like terms together, here I end up with 3x squared minus 7x plus 9x, so that leaves me with plus 2x. And then 12 plus 4 is 16. And once again, this is mega coincidence here. If I were to subtract 3x squared from each side, they would cancel themselves out. Really, for a lot of these, this would end up in a quadratic. Okay, but for whatever reason, these first couple examples, and I think that's true in your homework packet too. They've got them set up so they work out really nicely. So what I'm left with now is just 2x plus 16 equals negative 16. Okay. Subtract the 16 from the other side, and I get 2x equals negative 32, which means x must equal negative 16. Okay, so we've gone through this twice now. Hopefully you're surviving. Hopefully it's starting to sink in for you a little bit. One more. Now, I hope you can recognize the difference between this problem and the ones that came before it. If you notice, these ones all ended in a whole number, right? This one ends in another fraction. That actually is not as bad as it sounds, but we're going to approach it the same way. So I'm going to take my denominators. Now, technically, I have 3 to worry about. And so really, I should be multiplying by all 3 of them, which is gross. But 2 of them are the same, so I can actually get away with x minus 1 times x plus 2. I don't have to repeat the x plus 2, and you'll see why in a second. So when I go to do my first one, the x minus 1's cancel, and I'm left with these 2 things. So I'm going to write that as x times x plus 2. Oh, minus, so we're going to have to be careful with this one. Here we have x plus 2 times x plus 2, so I'm left with x plus 1, x minus 1. Equals, the only difference with this one is because I now have a fraction over here, I can do the same kind of thing. I can cancel out the x plus 2's and say I'm left with x minus 1, x minus 1. Okay, now let's see how the rest of this problem shakes out as far as like things dropping out of here. That's going to be different every time. So here I'm just distributing x squared plus 2x. Okay. Here, I'm going to write it like this. I'm going to write minus parentheses, and then I'm going to do my FOIL. So this is going to give me x squared. This is another one where the insides and the outsides are going to cancel themselves out, negative 1 and positive 1. But then my last term, 1 times negative 1 is minus 1, equals, so x times x is x squared. Now be careful here. These ones do not cancel. You have a negative 1x and a negative 1x. So you end up with negative 2x. And negative 1 times negative 1 is positive 1. Okay? What I have to be careful of here is this negative sign right here is going to distribute here. So that technically this is a negative x squared. It's also going to distribute here. So it's going to turn this into a positive 1. Getting rid of my parentheses there. So when I combine my like terms this time, I end up with x squared minus x squared. So those cancel themselves out. So now I have 2x plus 1 equals, Now this side still has an x squared in it. Okay. Because that x squared is still there, I know that I'm ultimately going to have to use quadratic formula here because I still have a quadratic going on. So what I'm going to do is I'm going to move these two things over to this side so that I have it all equal to 0. So I'm going to subtract 2x from each side, and I'm going to subtract 1. Okay. So I have 0 equals, that's what you want when you do quadratic formula, x squared minus 4x. Okay. And then 1 minus 1 cancels itself out, so this is just our quadratic. But I'm still going to go use quadratic formula. Technically, we could use factoring here, but we haven't talked about how to use factoring to solve yet this year. So I'm not going to worry about that right now. Okay, so quadratic formula program. Again, my quadratic formula, not my favorite. I'm going to hit regular. Okay, my a value here is 1. My b value is -4, and then the thing to be careful of is your c value. There's nothing there, so it would be 0. Okay? And I ended up with 4 and 0, I believe. Okay, so x equals 4, or x equals 0. And if you think about both of those values being plugged in here, both of them would work. Okay. So we didn't quite run into the thing that I wanted to show you. So I'm going to go back and mention it very quickly here because we have to be really careful when we're working with these fractions. And even more careful when we're doing it this way because we're getting rid of the fractions so early on, sometimes we forget that they are fractions. When you're working with fractions and denominators, you have to be careful that your denominator never comes out to be 0. So if I look at this x equals 4 and x equals 0, if I were to plug those back in for x, none of these denominators would come out to be 0. Okay, I could plug in a 4 or I could plug in a 0 and they would all be just fine. So these answers are good to go. But if I had done this whole process and found, let's say, for example, x equals 1, which it doesn't, but let's say that that's what our answer came out to be. When I look at this up here, having x be 1 was going to give us a problem, right? I can't have a 1 go in the denominator down there. So if that were the case, I would cross this off, okay? If I had another solution, if it was one of these where I had 2 and the other solution was okay, then I would just say that was my answer. If it's something where this was the only answer I got, like in one of these first 2 where I only got 1 answer, then I would just cross it off and say there is no solution, okay? I was kind of checking that as I went, but I thought I had one on here where that happened, so I was waiting for that to happen. It didn't, but that's okay. But like this one, -16, if I look back at my denominators, -16 isn't going to cause me any problems. But I have to remember to watch for that because I do believe that happens on some of your homework problems. Okay, I know this is a lot to look at all together in one place, but I am going to put a screenshot of this on Google Classroom along with this video. Hopefully it will help you out. Do the best you can on that section C and D tonight, and we'll make sure to go over them tomorrow. Okay, thanks for your time.